Hello friends, welcome back. Today we will discuss about inventory control. So in inventory control, we will discuss about four different models in the inventory control. So let's start inventory control. First, we will introduce the first model. So prior to that, we will discuss about some introductory about the inventory control. So in introduction, we have few terms related to cost, and first cost we have is ordering cost. So we can say that order cost. So order cost, what will say that order cost? So whatever the rent, salaries, traveling allowance, stationery, telephone bill, electricity bill, all these type of bill occurred with the purchase department. So whatever the bill extra cost occur with the purchase department is nothing but the ordering cost or order cost. So if you have annual demand of A and you are so let us say 1000 quantity. If you have annual demand of 1000 quantity and if you have monthly consumption of 100 quantity, then you have to place 10 orders. So for satisfying the 1000 of annual demand, you have to place 10 orders. So for those 10 orders, you have to place 10 orders. So you have to pay some extra cost like telephonic cost, stationery bill. If some person is going to purchase that particular quantity, then you have to pay traveling allowance for that particular customer or for that particular employee. So that particular cost will also come in this category, and that will be the ordering cost. So that will also come in the ordering cost. So we have different costs which is associated with the ordering cost, and those costs can be like rent, like salaries, traveling allowance, stationery, telephonic bill, electricity bill. All these costs of the purchase department will come in the category of ordering cost. So if you have annual demand of A and the ordering quantity is Q, annual demand is A and ordering quantity is Q, and cost per order, this is the S, and we will say that this is the cost per order. Cost per order is S. Then total ordering cost will be A by Q into S. Let us say if we have annual demand of 1000 quantity and we are placing order of lots of 100 quantity, then we have to place 10 orders, and for if S is the ordering cost per order, then 10S will be the total ordering cost. So we have to pay 10S. If it is S is let us say 3 rupees or 2 rupees, then we have to pay 20 rupees or 30 rupees of ordering cost for ordering the for placing the orders. So we have discussed about the ordering cost. Next we will talk about the inventory carrying cost. So variables in the ordering cost are A is the annual demand, S is the cost per order, and Q is the order quantity. So we have discussed Q is the order quantity. Next we will talk about the inventory carrying cost. So we will discuss about the inventory carrying cost. What is inventory carrying? So we will discuss about the inventory carrying cost. In inventory carrying cost, we have a different cost. Whatever the cost associated with the store department or store, that will say that is the inventory carrying cost. So whatever the cost occurred in the store section, that will come in the category of inventory carrying cost. So let us say if you have rent, salaries, or traveling allowance of the employee associated with the store section, that cost will come in the category of inventory carrying cost. So it may be of a stationery bill, telephonic bill, or traveling allowance, or electricity bill associated with that particular store section, that will say that is the inventory carrying cost. So if we have initial inventory, if we are placing the order, if we are receiving the quantity in the size of Q, so if we have initial quantity received is quantity Q, finally we will consume after the time, so final inventory will be 0. So average inventory will be Q plus 0 by 2, and if CI is the inventory carrying cost, then total inventory cost will be Q by 2 into CI. So average inventory carrying cost, that will be Q by 2 into CI, where Q is the lot size or quantity we are going to order, and that will be initially Q and finally it will be 0. So finally total will be, or you can say average will be Q plus 0 by 2, and CI will be the inventory carrying cost per quantity. So total inventory carrying cost, or we will say that average inventory carrying cost. So we can say that average inventory carrying cost will be Q by 2 into Ci. That will be the value of average inventory carrying cost. So we can find inventory carrying cost. We can also talk about the ordering cost, or we can say that order cost. So we have discussed two different type of cost. One is the inventory carrying cost, and another is the ordering cost. So sometimes what will happen in the given problem, you might have find that is this inventory carrying cost will be given as the I, and it is the percentage of inventory carrying cost, and also C, which is the cost per unit. So total inventory carrying cost, we will find inventory carrying cost per quantity, we will find that C into I. So an average inventory carrying cost we will find by multiplying with the term Q by 2, where Q is the ordering quantity. So we have discussed about the ordering cost and inventory carrying cost. Next we will discuss about the. So let us discuss about this particular plot. So very interesting plot. This is very interesting plot. So this is the plot between quantity, ordering quantity, and the time. With the time, what will happen? So initially, what will happen? You are receiving the order, and that order will be in the quantity of Q. So initially, you have order, and when that is the quantity of Q. With the time, what will happen? You will consume this quantity. So after consuming this quantity, there will be, if you will consume this quantity, what will happen? You have after a significant time, after your consumption time, it will be 0. So when that quantity will be 0, again you are receiving a fresh order, and that quantity will be Q. Again with the time you are consuming it, and it will be coming at 0. So when again it will become 0, again you are getting a fresh order, and that order will be Q. So in a particular time period, and we will say in a particular consumption period, we have initial inventory 0, Q, and final inventory 0. So average inventory will be Q plus 0 by 2. So this particular plot is very, very interesting plot. We will discuss similar type of plot in different models. So this is nothing but plot between order quantity Q and time. So the time, consumption time, you can say, and the period you are going to do analysis like that. So we have discussed about the inventory carrying cost, and inventory carrying cost and ordering cost. Next we will talk about the ordering cost, or next we will talk about the economic order quantity. So what is economic order quantity? We will discuss over here. So what is happening is there. So we have two costs. So in the one is the ordering cost, and another is average inventory carrying cost, or we can say that this is the inventory carrying cost. So we have two costs. One is ordering cost, and another is the inventory carrying cost. So we have two different costs. One is the ordering cost, and another is the inventory carrying cost. So that together we will say that is the total variable cost. So total variable cost, we can write that A by Q into S plus Q by 2 into Ci. So in this particular term, we have two different costs. One is ordering cost, and another is the average inventory carrying cost. So we have two different costs. One is the ordering cost and order cost, and another is the average inventory carrying cost. So what is happening here over here is that, so this particular total variable cost is decreasing with the increase in the lot size, or you can say order quantity. So we have Q as order quantity. So if you increase the order quantity, this total variable cost is decreased because ordering cost will decrease. On the other side, if you increase the order quantity, what will happening is this total variable cost is increasing. Why it is increasing? Because average inventory carrying cost is increasing. So if you order more, what you have to do is you have to carry that particular order, because it will take more time to consume. So you have to carry the orders, or you have to carry the quantity for longer period. So what will happen? There will be a more inventory carrying cost. So you have to pay more inventory carrying cost. So what we will do, what is happening over here is that one quantity is reducing, and one is increasing, and another is reducing, or you can say one is reducing and another is increasing. So if you increase the order quantity, this ordering cost will increase. On the other side, inventory carrying cost will decrease. So what we are doing, we are going to find some optimal value of order quantity, so that we can have a optimal total variable cost. So for that, what we will do, we we are seeing over here that this particular variable cost is a function of quantity Q. So if you say total variable cost, so we have total variable cost which is a function of Q. So for finding the minimum value of total variable cost, what we'll do, we'll differentiate the total variable cost as a function of Q and we will equate to 0. So we will, for finding the minimum value of total variable cost, what we'll do, we will differentiate the total variable cost with respect to order quantity Q and we'll equate to 0. And we'll go for finding the value of Q. Assuming that there will be some constant, and those constants are, we have constant demand. We are assuming over that the demand is constant, inventory carrying cost is also constant, means C and I, value of CI is constant. There is no any lead time. So lead time, the value of lead time is 0. We will say that lead time is the, let me know what is the lead time. Lead time means if you are placing order today and after 4 days if you are receiving the order, so that particular 4 days is nothing but the lead time. So that is the lead time. So we are assuming over here that annual demand inventory carrying cost is constant and there is no any shortage. So if we have a demand, we will fulfill that demand. There is no any shortage of the quantity and also there is no any lead time. So assuming these 4 assumptions, what we'll do, we'll find the minimum value of total variable cost. So we can find the minimum value of total variable cost by differentiating total variable cost as a function of Q and equating to 0. So after solving this, we have the total variable cost as A by Q into S plus Q by 2 into Ci. So if we will differentiate this, we will find the differentiation of 1 by Q is minus 1 by Q square and differentiation of Q is 1 over here. So if we simplify this, we will find the value of Q, and Q we are writing over is as Q star, and this Q star will be 2 times AS by Ci. This particular Q star is known as economic order quantity. So we have obtained an expression for economic order quantity. This particular relation, above relation formula, we will say that Wilson's formula for finding the economic order quantity. So this is the Wilson formula for finding the economic order quantities, that what is the value of economic order quantity. So we can find the value of total variable cost at economic order quantity, and that particular cost will be A by Q into S plus Q by 2 into Ci. If we will replace the value of Q star as 2S by Ci, so if we replace the value of this as 2S by Ci, we will simplify this. So if we replace this by 2S by Ci and we will simplify it. So after simplification, we will get that the total variable cost will be 2As into Ci. So it is very simple to remember. Q star is nothing but 2 times 2 ASIC, 2 times ASIC. So where As is in the numerator and Ci is in the denominator. But in the total variable cost, it is 2 times ASIC and this is completely in the same. So there is no any proportion and there is no this fraction symbol. So it is very easy to remember economic order quantity, that is 2S by Ci, and total variable cost at economic order quantity will be 2AS Ci. So here it is product of 2s and into Ci, and it is the fraction of 2s into Ci in the square root, and there is also a square root. So we can find the value of total variable cost as well as economic order quantity by using this formula, and we can also find the total annual cost. So this is the total cost and that is the total annual cost. This means what is the cost going to be occurred in the annual. So for that particular annual demand A, so we can find that annual cost as A into C plus TVC, and that TVC will be A by Q into S plus Q by 2 into C. So total annual cost at any quantity, particular quantity Q, will be A into C plus Q by A by Q into S plus Q by 2 into C, where A into C is the fixed cost, this is the ordering cost, and this particular value is the inventory carrying cost. So this particular ordering annual cost, total annual cost, is nothing but that ordering quantity Q. So we can also find the value of total annual cost at particular given at particular quantity and at optimal quantity, and that quantity will be Q star. So we can find the total annual cost at Q star, and that Q star the total annual cost will be A into C plus 2 times A into C, A into S into C I. So we can find total annual cost by using this formula or by this formula. We have to remember both the formula, because sometimes what happening in the question, they will give you quantity as a function of something or some constant as a function of quantity. So it is better to remember both the formula, total annual cost at particular quantity Q and also at some quantity at optimum quantity, or you can say at economic order quantity Q star. Now we will go for solving some problems. We will discuss some problem. So we have one question on the basis of this model we have discussed of the inventory control. So in the question, a company purchases 200 quantities. So one company is there which is purchases 200 quantities. 2000 quantity. So there is an annual demand of 2000 quantities. So A will be 2000 quantity of a particular items of some particular item per year at a unit cost of rupees 20. So the unit cost of that particular item is nothing but 20. So C will be 20. Ordering cost per order is rupees 50. So by the unit we will discuss, we can identify what is the variables we have given. So here you can see that cost per order. So this is nothing but ordering cost. So S, this is S. And the inventory carrying cost is 25%. So it is the value of I, and that I is nothing but is a fraction of percentage of the unit cost. So inventory carrying cost is 25%, means rupees 5. Rupees 5 will be 25% of rupees 20. That will be 5. So rupees 5 will be inventory carrying costs. Next we have to find the optimal order quantity. So we have to find Q star and minimum total cost including purchase cost. So we have to find total annual cost, and it is saying that we have to find minimum value. So minimum will be at Q star. So we have to find Q star, and also we have to find total annual cost at Q star. Very easy question. We can find this particular solution. We can solve this particular question by very simple. So second part of this question is there. So if a 3% of discount is offered by the supplier, so supplier what is doing is it is giving some attraction as a terms of discount. So we'll see that this particular discount is favorable or not. We have to accept this discount or we have to reject this discount. So if the value of discount, if the total annual cost after this particular discount is coming more than this minimum total annual cost, then we will reject the discount. And if it is coming lesser than this particular total annual cost or this particular minimum annual cost, we will accept that particular discount. So we are going to solve this particular question. So whatever the terms we have given, we will mention over here. So we have annual demand of 2000 quantity, unit cost is rupees 20. This is in the rupees, this is in the rupees per order. So ordering cost is rupees 50 and this is per order. Inventory carrying cost is 25% of the unit cost, and that CI will be 25% of 20, and that will be rupees 5. So we have some parameters given. We will find the EOQ, and EOQ we can calculate by 2S into CI. 2A is the 2000, S is the rupees 50 per order, and this is per order. So we have rupees 50 per order. Inventory carrying cost is rupees 20 into 0.24 and 25, and that will be rupees 5. So we can put the values and we will find that there is a economic order quantity of 200 units. So for this 2000 quantity, if you are placing the order in the lots of 200 units, means number of orders will be how much? A by Q star, and that will be 2000 by 200, and so this will be 10. So number of orders will be 10. Number of orders will be 10. So we can find the total annual cost for economic order quantity, and we can find this particular total annual cost is EOQ at 2S AC plus 2S CI, and we have AC as 200, A is 2000, C is 20, and these values we have given. So after solving, we will find that the total annual cost at economic order quantity is 41,000. So this is the minimum total annual cost. So after getting discount, so we'll see that what will be the value of total annual cost. So based on the discount, we'll find that what will be the value of total annual cost, and after that we'll compare the two costs, and we'll see if it is minimum after discount, we'll accept the discount, and if it is not, then we'll reject the discount. So it is saying that there is a 3% discount if you are ordering in a lot size of 1000 and more. So if you are placing the order, instead of having 200 quantity, if you are placing the order in a lots of 1000 and more, so we are placing the order in the lot size of 1000 quantity. So there is a offer, there is a discount of 3%. So this 3% discount will be on the unit cost. So your cost will be 3%, means 0.97% of 3C. So we have to pay, we don't have to pay rupees 20, we have to pay 97% of rupees 20. So we will find the cost after discount, and we will compare. So this is the minimum total cost we have to find. So we will find the total annual cost after the discount, and we can find the total annual cost after discount by subtracting by placing the C in as a multiplier of 0.97%. So we can find here the value of R is 3%, so 1 minus 0.3 means this is 0.97, so 97% of C. So wherever the C terms, we will place this particular discount term. So this discount term will come over there. So annual demand we have 2000 quantity, C we have 20 rupees, and discount we have 3%, so this is 3 by 100. This term will remain as it is. There is no any change in this particular term, so third term will change. This term will remain as it is, and third term will change, and the change will be in the unit cost. So this is the change in the unit cost. So after solving this particular value, we will see that the value of total annual cost after discount is 41,325. So if you solve this particular term, you will get 41,325. But the minimum cost is 40,000. So minimum cost is 41,000. We have seen that minimum cost is 41,000. So we have seen over there that the minimum cost is 41,000. So we can see that we can compare that the total cost after the discount is higher than the minimum cost. So what we'll say that we'll reject the discount. So we reject the idea of discount. Total cost with the discount price is more than total annual cost at economic order quantity. So we'll reject the offer and will not accept the discount. We have another one question in the similar way. So we have to find EOQ, economic order quantity, we have to find Q star, we have to find, then we have to find the number of orders. So number of orders will be A by Q star, and we have to find with the policy of ordering every month. Instead of placing the order in a lot size of Q star, if we are placing the order every month with them. So we will see what would be the annual cost as a percentage of the cost at EOQ. So total annual cost with monthly will be as a percentage of total annual cost at Q star into 100. So we will find the value of this. So we have to find these three terms: Q star, A by Q star, and total annual cost monthly by total annual cost in the EOQ into 100. So we will find these values. So we have given demand, annual demand is A, and that is 1000 quantity. Order cost means that is S, cost per order. Holding cost is 10% of inventory carrying cost, and that is unit cost is 50. So inventory carrying cost CI will be rupees 50. So CI will be have 50. So I is 10%. So CI will be 50 rupees 50. That will be the inventory carrying cost. So we have annual demand of 1000 quantity. We have annual demand. C is the unit cost, and that cost we have given is rupees 500. Next cost, that is the order cost, and that is the rupees 40 per order. Inventory carrying cost, which is the percentage of unit cost, and that is the 10%. Next, we will find on the basis of given parameters, we will find the value of Q star, and that will be the 2S into CI. 2 into 1000 into S is the 40. C is the C value of C is 500, and I will be 0.01. So we'll solve this, and we can see that the economic order quantity is 40 units. So if you order in lot size of 40 orders, then we have economic order quantity, we have minimum total variable cost. We can find the number of orders, and number of orders will be annual demand by Q star, because there is a demand of 1000 and Q star is 40, so we have 1000 by 40, and that will come with as 25. So we have number of orders as 25. So this is the answer of B, part B. Next part we have to find the total annual cost by comparison of total annual cost if we are placing the order monthly. So we will place the order monthly, the number of orders will be 1000 by 12. So this will be the number of orders. So number of orders will be 1000 by number of orders will be 1000 by 12. So we'll find for ordering every month. So if you're ordering every month, so the number of or you can say instead of number of orders will be 12. It is nothing but number of quantity, not orders, number of quantity. Number of quantity will be 1000 by 12. This is not order. Since we are placing order every month, so number of orders will be 12. Number of orders will be 12. So number of orders will be 12. So and number of quantity will be Q will be 1000 by 12. So that Q will be 1012. So total annual cost at Q will be A into C, A by Q into S, and Q by 2 into CL. So we'll find the total annual cost at Q, and we'll also find total annual cost at Q star. So A and C we have known. A is 1000, C is we have given 500. So and A by Q will be 1000 by 12. So it is C is 500, A by Q will be this value. So we will solve. If we will solve this, we will find that total annual cost will be at this particular quantity, this particular order quantity will be 5,02,563. So now we'll see that total annual cost at economic order quantity. So we have economic order quantity, and we have ordering size is 40. So we can find the total annual cost at EOQ, that will be 2A into S, A into C plus 2 times A into S, CI. If we will place the values of constants, so we will find that the total annual cost at Q star will be 5,02,000. So if you are ordering per month, you have total annual cost. So it is better to order at EOQ. So we can place the order at EOQ. We will see this how much percentage there is a variation in total annual cost with respect to total annual cost at EOQ, at economic order quantity, and we can see that there is a variation of 100.11, means 0.11% there is a change in the if we are placing the order every month. So it is better to go for ordering at EOQ. Always it is better to place order at economic order quantity. So we have discussed economic order quantity, total variable cost, annual cost. We have calculated number of orders, also those parameters we have discussed. So we have discussed first module of economic order of inventory control. Next, in the next lecture, we'll discuss about the second model of inventory control, and that particular model is simultaneous production consumption model. So we'll discuss this particular model in the next lecture. Thank you so much for attending the class, attending the lecture. See you in the next lecture. Thank you so much. This model, what we are doing is we are producing, not only producing, we are also consuming with the same time. So we are producing as well as we are consuming. We are selling, or you can say we are supplying the demand by producing on our own self. So we will discuss this particular model. So in this model we have some variables. Let us see, we have A as annual demand. So we have annual demand as A, and S is setup cost. So we have annual demand, there is a requirement of requirement of quantity is A. Setup cost is for producing one item, we have setup cost, and that cost is S. And we have another cost, actual cost of the product, and that is cost per unit time, and that cost, or you can say cost per unit is C. And we have inventory carrying cost, and that is I. So we have here we have production rate, consumption rate, and production time. Three terms we have. One is production rate, another is consumption rate, and we have production time. So let us see these variables with a simple plot. So we have a plot with in between time and quantity. So same like earlier one, we have plot with time and quantity. So what will happen if you are producing some with some rate? So we are producing with some rate, and that rate is P. With P we are producing. So if we produce with P, so we have some quantity, let us say Q. But what we are doing, we are not only producing, we are also consuming some item. So because of that, there is a decrease in the quantity. So that quantity will be I max. Why? Because we are not only producing, we are also consuming. Here we have model having both the things, production as well as consumption. So we have production rate, so we are producing the quantity, number of quantities per unit time by P, and we are consuming the same item by R. So we have production rate P and consumption rate R. So maximum inventory that can be stored with this production rate and consumption rate is I max. So we have production time, one time we have, that time is production time, but we have another time also, consumption time, but consumption time will be from this point to till the consumption of this particular quantity. So this whole time is nothing but consumption time. So we are consuming till this period. So when this I max will be consumed, what we will do, we will again start production. So we will again start production, and we have also we have regular consumption. So we have P minus R, again P minus R as a inventory. So we have inventory with the rate of P minus R, and maximum inventory we have stored is I max. So again we have production time. So for this time we are producing the quantity, and we are repeating the same thing. So again this cycle will be repeated, and again it will go periodically. So this is simple schematic, simple diagram in simple plot between quantity and time. So maximum inventory we are getting is I max, that is the maximum inventory, and this is because of the production, and we have some also consumption rate. So production rate minus consumption rate will store the inventory, and that inventory, that maximum inventory we are going to have is I max. So next we will discuss, again we have discussed these things. So next we will discuss some formula related to simultaneous production model. So we have first formula about simultaneous production model, and that first formula is EPQ. So in EPQ what we are doing? So in EPQ we have first formula, and that formula is EPQ. So we will see what is EPQ. So very first formula we have EPQ, that is economic production quantity. So economic production quantity we have. So what we will say, economic production quantity we have EPQ, and we have a formula for EPQ is this formula. So let us see what is EPQ. So economic production quantity, that is the quantity we are going to produce that will give maximum profit. So what should be the quantity, so that we can, if we are producing that quantity, we have a maximum profit. So for that for finding that particular quantity, that is EPQ, and we are denoting this by P star, we can calculate by this particular formula, where A is annual demand, S is setup cost, and CI is inventory carrying cost, P we have production rate, and R we have consumption rate. So we can find economic production quantity by making use of this particular formula. So we can, EPQ we have economic production quantity, and we can also known it as economic back quantity, or we can say economic lot size. So this is the economic lot size. If we are going to produce this particular size, then we will have a maximum profit with the same setup. So we can find EPQ by another way also. So EPQ, economic production quantity. So some quantity we have. So let us see if this value is EPQ. So EPQ, how we can find? If it is EPQ, so EPQ we can find, we have a production rate. So production rate, how we will find production rate? Quantity produced per unit time. So quantity produced, that is EPQ per unit time. So that is TP. So we can find EPQ by cross multiplication of this. So we can find EPQ by P into TP. So one way for finding the EPQ by this formula, and this formula we are getting by differentiating the total variable cost in this particular model with quantity and equating it to 0. So we will find this particular formula for economic production quantity. Another way for finding the economic production quantity by making use of production rate into production time. This will give you the economic production quantity. So we can find TP also from this particular formula if one is not given. If EPQ is known, P is known, then we can also find TPQ, and that will be equals to EPQ by P. So we have here maximum inventory formula also. So how much maximum inventory we are going to store, and that maximum inventory we have is P minus R. This is the P minus R into TP. P minus R into like this way, P minus R into TP will give you I max. Like we are getting EPQ by the formula P into TP. In the same way we can find EPQ by the formula P into TP. In the same way we can find I max by P minus R into TP. So I max is nothing but the maximum inventory we are going to store. So the maximum inventory we have in our hand, that maximum inventory we can find by the formula P minus R into TP. We can also find the formula for number of production runs. So how many times we are going to produce, and that means, see, we have produced already here 2 times. So what will be this number 2, 3, 4, 5, so that we can have complete supply of annual demand A. So we can find this particular setup by A by this formula A by EPQ. Like earlier model we have found the number of orders, and that is A by EOQ. In the same way we can find number of production runs, because we are producing on our own. So we have to run the setup, and how many times we have to run, that number of times we can find by A by EPQ. So this formula will give the number of production runs we have to make, so that we can have a complete supply of this particular demand, and that demand is A. So we can find some other parameters also in the same way like in the earlier model we have found. So we can find the total annual cost. So total annual cost we can find by fixed cost plus total variable cost. So we have fixed total variable cost and total variable cost at economic production quantity we can find by this particular relation, this particular expression formula. So economic production quantity we can find annual demand, setup cost, inventory carrying cost, production rate, consumption rate, like that. So we can find total variable cost by making use of this particular formula. In terms of this particular formula we can find also the total annual cost. So total annual cost will be at EPQ will be A into C plus total variable cost, and total variable cost is nothing but 2 into ASCI into P minus R by P. So by this formula we can find the total annual cost, and by this formula we can find the total variable cost. So we can find total annual cost, total variable cost by making use of this formulae. So next we will talk about the total annual cost at sum in general quantity Q. So we can find total annual cost at sum in general quantity Q, and that will be equals to fixed cost. Fixed cost annual demand into unit cost plus we have setup cost, or you can say in the earlier model we have ordering cost. Like that we have setup cost, and this is we have inventory carrying cost. Because maximum inventory is I max, minimum inventory we have is 0. So we can find the average inventory by I max plus 0 by 2, and this will give you the inventory carrying cost. So we can find total annual cost, total variable cost in both the model. This will also give you the total variable cost, and this is total annual cost. So we can find total annual cost, total variable cost by making use of this particular formula. So we have discussed few formula related to the production consumption model. Next we will talk about one question, and that question is, this is the question, and we have to find, number of production runs. So how many times we are going to produce, what will be the number of times we are going to produce, and also the total incremental cost in factory for the following data. So we have to find total incremental cost. So we can find total variable cost, that will be the total incremental cost in a factory for the following data. So we have to find total incremental cost, means total variable cost we have to find, and number of production runs we have to find. So total incremental cost, that is total variable cost, we can find at Q also, and that is A by Q into S plus I max by 2 into CI. So by this formula we can find, or if you have to find total also the total incremental cost, so we can find by making use of this particular formula. So total incremental cost we can find. So we will see how we can find, and we can find the number of production runs, and that is A by APQ. So number of production runs we can find by making use of this particular formula, and total incremental cost, that is total variable cost or some general quantity Q, we can find by this particular formula. Or we can say if Q is not given, so we can find total incremental cost at EPQ. Total incremental cost at EPQ we can find by making use of this particular formula, and that formula is 2S CI into P minus R by P. So we can find total incremental cost by making use of this particular formula. So that is total incremental cost or total variable cost at EPQ will be equals to 2AS CI under root into P minus R by P. So by making use of this particular formula, we can find total incremental cost at economic production quantity. So let me discuss the things we have given. So we have some parameters given, and that those parameters are, we have annual demand of 15,000 units. So we have annual demand of 15,000 units, and we have production cost, that is setup cost per product, per order, or per production. So we have our per production run, this is 25 rupees 25. Inventory holding cost or carrying cost, that is CI, and we have rupees 5. So we have CI. So sometimes it is given I, sometimes it is given CI both. So how we will judge what is given, and that can be judged by the time unit that is given. So if I only I will be given, then there is no any terms of rupees or cost or dollar. So if CI is given, then there will be a unit also of rupees. So we have inventory carrying cost, and that is rupees 5 per unit. So if you are storing one quantity, you have to pay inventory carrying cost of rupees 5, and that is for 1 year. Production rate we have 100, and number of working days in 1 year is 250 days. So we will find the consumption rate, and consumption rate is how much we are consuming 15,000. So we are consuming 15,000 in how much days? In 250 days. So this will be the consumption rate. So we can find consumption rate by this formula. So we can find consumption rate, and we have production rate is 100. So it is given over there. So consumption rate will be, we have consumption rate, and that is A by 250, and that we can find consumption rate by 60 units per day. So this will be the consumption rate. Now we will find the EPQ. So R is 60 units per day. So we have consumption rate 60 units per day, and we have also production rate 100 units per day. So we are storing 40 units per day. So this is nothing but in inventory we are storing 40 units per day. So next we will talk here we have production rate is more than consumption rate. So we can use production consumption model for this particular problem. So we can find production in the with the help of production consumption model, the EPQ. So what will be the economic production quantity? So economic production quantity will be 2S by CI into P by P minus R. We have given A as 15,000, S 25, CI is rupees 5 per year, production rate 100, and consumption rate is 60. So we will put these values, and we are getting that economic production quantity is 612.4. So it can be 612.4, or you can say it can be 613. So its economic production quantity is 612.4. So this is the quantity it will give you the maximum profit. So if you are producing with this number of quantity, you will have a maximum profit you have. Next we can find, so we have a PQ at 60. We have we have solved EPQ, and that is 612. Next we will find the Imax. So what is the Imax? So Imax we can find by P minus R by TP, and Imax we can find by the formula Imax equals to P minus R. This is production minus consumption rate, and into rate, this is rate. If you multiply the rate with the production time, you will get the quantity, and that quantity will be the maximum inventory we are going to store, and that storing quantity we can find. So we have to find first TP, and TP we can find by TP we can find the formula TP equals to production rate EPQ, economic production quantity, by production rate. So with this formula we can find TP, and TP we have. So we have TP, value of TP, and how we can find the value of TP. So we can find the value of TP as TP we can find. So TP we have TP you can find by this formula EPQ by P, and EPQ we have 612 and we have production at 100. So TP will be EPQ by P, and that will be 612 by 100, and that is 6.124 days. So production time is 6.124 days. We will go for fraction only. We will not go for integer. So we will leave it as a fraction. So production time is 6.124 days. Production rate is 100. Economic production quantity is 612.4. So now we have maximum inventory, and that maximum inventory will be production rate minus consumption rate into production time. Production rate is 100, and that is 60. So 40 into 6. So 40 into 6. So this will give you around 245. So maximum inventory we are going to store, and that storing inventory is nothing but 600. That is the 245. So this is for one production run. So this is for production days. Number of production days 6.124 days. So this is the production days. So per production run we are storing maximum inventory, at that maximum inventory is 245. We can find the number of production runs by making use of this particular formula, and number of production run is A by EPQ. A is annual demand, and that is 15,000 quantity, and economic production quantity is 612.4. So 612.4 divided by 15,000. So number of production runs will be how much? 24.5. So around 24.5 times you have to run this production, so that we can have a production quantity of 15,000, and you can find this particular value. So number of production runs we have. Now we will find total variable cost at EPQ, and we have formula that is the square root of 2AS CI into P minus R by P. So we have seen this formula. So we will find this particular formula. We have discussed this formula over here. So with this formula we can find we have formula for this, and we have this formula is EPQ for formula P minus R by P. So 2AS CI into P minus R by P. So we can find total incremental cost or total variable cost. So by this making use of this particular formula, so we have total incremental cost, or we can say total variable cost. So that will be 2AS into CI P minus R by P. So here 2A is how much? A we can have 15,000, S is 25, CI is 5, and production rate is 100, consumption rate 60, and it's 100. So by solving this for this relation, we can have a total variable cost, and that is called total incremental cost at this particular quantity. In general quantity we can also find for in general quantity, but that quantity is not mentioned over here. So we will find total incremental cost at economic production quantity, and this will give you the answer. So with this we have completed a few things about production and consumption model. So next we will talk about the inventory control, and in this case we will discuss another model, and that model is inventory model with shortage. So we will discuss about inventory we are allowing shortage. So we'll see a few few new terms over here. So we have simple plot, and one plot is we have we have quantity and time. So first we are discussing the plot, and that plot is quantity with time. So initially we have some quantity and we are consuming this quantity. So this quantity will become 0, and at this point there is a demand, and that demand is a quantity S star, but we don't have any supply. So because we don't have any supply, so what we have a shortage of quantity, and that shortage. So if we have shortage, so we can have a maximum, we can have a minimum shortage, so that we can have a minimum losses. So shortage will give you some losses, and that losses will be in terms of, because you have a shortage. So what will happen? The customer who is arriving at your store, at your plot, at your plant, so they will return. They will not have sufficient quantity. So there is a demand, but you don't have any quantity. So the customer will get a return. So because if you able to solve, if you able to sell some quantity with that customer, you will have some profit. But because that customer getting return, so there may be chance that that customer will not come in the future. So it will also give loss in the another terms. You have also since you have you don't have quantity, sufficient quantity, you don't have quantity to supply the demand, but the employees associated with you or your company, they are working, so you have to pay the salaries for that. For those employees, you have to pay the rent for you have, if you have hired some office, if you are consuming some electricity bill, some telephonic bill, so you have to pay for that, and those costs will come under the category of shortage, because you don't have any supply and you have demand, but you are not able to sell the product. So that's why you have some shortage, and that shortage will give you as a loss, as a penalty. So that cost we will target that cost should be minimized. Whatever the possible way, we can have a minimum shortage, and we can have minimum shortage cost. So we'll discuss. So here this is a plot, and this plot is in between the quantity and this time. So we'll see how this quantity and time is altering or changing the shortage inventory model. So we have some demand Q star, or you can say EOQ, economic order quantity. So if you have this demand, when you supply this quantity, when you have this quantity, this quantity will consume, and at this time we don't have any quantity in hand, but there is a demand, and that demand is S star. You don't have any quantity, but there is a demand, and that demand will go as shortage. So initially you have Q star quantity, and finally you have shortage, so that is S star. So we'll see again this quantity you are getting, and you are consuming this quantity, and at the time here we have 0 quantity, but there is a demand, and that demand will go as a shortage. So we have this will go repeated in periodic. So each time you are having a lot size, and you will consume that lot size, and after some time you have some for some period you have shortage of quantity, and that time period is T2. So here we have some variables we have used Q star, and that Q star is economic order quantity EOQ, and S star is the optimum shortage. So there is a shortage, so what we will target is, so we can reduce the shortage, and we'll try to minimize the shortage, and that quantity will be optimum shortage. We have also shortage cost, and that cost is CS, because if you have shortage, so that will give you some penalty, and that penalty is shortage cost, and that cost is CS, and that is per unit per year. We have two times, one is consumption time, or we have also second time is, that is shortage time. Here we have some cost, and that cost is purchase cost, that is the fixed cost, and that cost is purchase cost, and that is A into C. We have also another cost, and that is similar to we have order cost, and that ordering cost or order cost is A by Q into S, like earlier model, first model we have. We have also inventory carrying cost, and that is maximum inventory by 2 into CI. So maximum inventory, how much we have? Q star minus S star, because so maximum inventory we have Q star minus S star, minimum inventory is 0, and finally we have Q star minus S star by 2 will be the average inventory. So we have inventory carrying cost is Q star minus S star by 2 and into CI. So this CI is inventory carrying cost per unit, and number of quantities we are getting from I max by 2, and that is Q star minus X star by 2. So this value will give you the maximum inventory we have. So again we will find some shortage cost we have, and the shortage cost, initially we have zero shortage at this particular point, and at this point of time we have maximum shortage, and that shortage is S star. So here we have no shortage, so this is 0 plus S star by 2. So this will give you the average shortage, and if you multiply this average shortage with shortage cost, you will have a shortage cost, total shortage cost. So we have shortage cost S star by 2 into CS, and we have also another cost, that is total variable cost. So total variable cost, we have three terms in the total variable cost. One is the ordering cost, inventory carrying cost, and third one is the shortage cost. In the earlier model we have only two costs, but one extra cost come here over here is the shortage cost, and that cost is S star by 2 into CS. Average quantity shortage into shortage cost per unit. This is average quantity carried or holding and into holding cost per unit. So this will give you the total variable cost. And if we talk about the total annual cost, so this fixed cost will come, and this will give you the total annual cost. So this is the fixed cost, or you can say purchase cost, ordering cost, carrying cost, inventory carrying cost, and this is your shortage cost. So we can find the optimum shortage also. So optimum shortage, or you can say if we have shortage, then what will be the economic production what will have the economic order quantity. So economic order quantity Q star for including the shortage will be the 2S into CI, where is a annual demand, S is the cost per unit per order, CI we have inventory carrying cost, and CS we have shortage cost. We can also have optimum shortage, and that shortage can be calculated by this particular formula, where all the variables have same meaning what we have in the EOQ, economic order quantity. If you have ordering quantity, if you have at EOQ, what will happen at if ordering cost, inventory carrying cost, and shortage cost are equal, then total variable cost will be 3 times of any of 1, because all these three are equal. So at economic order quantity, if ordering cost, inventory carrying cost, and shortage cost are equal, then total variable cost will be 3 times of any of 1. So any of the following will give you, if you are multiply with 3, this will give you the total variable cost. Now we will discuss one problem which is based on the shortage model. So in the inventory model with the shortage, we will discuss this particular problem. So in this particular problem, there is demand of an item, and that demand is 25 units per month. So if you multiply by 12, then you have demand, and that is annual demand. So this will give you the annual demand A. So this will give you the 300 as annual demand. The fixed cost is rupees 30. So each time a production run is made, so this is the each time a production run is made. So this is nothing but the each time a production run is made is the, this is the setup cost, and that is S. The production cost is rupees 2. This is unit cost per item. So this is the C, production cost C, and inventory carrying cost is 50 paisa. So inventory carrying cost CI is 50 paisa per unit per month. So we'll convert this CI into per year, so we'll multiply by 12. So this will give you 6 rupees, because 50 paisa multiplied by 6. So if you convert into rupees, so you have to divide by 100. So this will give you in the rupees, into 12. So this will give you 6 rupees. So 6 rupees is the inventory carrying cost. So the parameters, the values given, will mark over here. So the parameters given is annual demand, that is 300 units per year. We have setup cost, or you can say production run. So each time we are running the production unit, so we have to pay an extra cost, and that is rupees 30. Unit cost is we have rupees 2. Inventory carrying cost we have half rupees per unit per month, so we have 6 rupees per year. And it is also mentioned that shortage cost is rupees 3 per unit per month, so we have shortage cost as 36 rupees per unit per year. So we have to determine how often to run a production and of what size. So we have to find number of production runs, means A by EOQ, and of what size. So we will find number of production runs, and we will find the size. So we can find production runs. So first we will find the economic order quantity. So that economic order quantity will be, we have mentioned this formula in, so 2s by CI into CI into, so we can find economic order quantity by this particular relation, 2s by CI into CI plus CS by CI. So we have A as 300 units, S we have 30, so we will place these values and we will get the economic order quantity, and that quantity is 59.16 units. So if you solve this particular expression values, unit cost we have 6 rupees as a inventory carrying cost, and shortage cost rupees 36. So rupees 30. So economic order quantity we have 59.16. Next we will find the number of production runs by A by Q, EOQ, and A we have 300, annual demand we have 300 quantity, because we have 25 quantity per month requirement. So number of production runs will be around 5. So it will be around 5, because it is around 60. So 300 by 60 will give you around 5. So number of production run is 5. Now we will find the optimum shortage. So optimum shortage we have 2s by CI, and we will put the values of these variables. We will find the optimum shortage quantity is 8.45. This is the optimum shortage quantity. Next we will find the maximum inventory, that is I max, and I max will be equals to Q star minus S star. Q star we have the optimum quantity is 59.16, and S star is this 8.45. This will give you 50.7. So this is the maximum inventory we have. So maximum inventory we have is 50.7, and we have economic order quantity is 59.16. Number of production runs is 5. So these are the values we have to find. So we have obtained these values in the shortage model. So we have discussed the shortage model, and we can find the value of maximum inventory we are going to store, and number of production runs we have to maintain. We have to go for finding the optimal order quantity, EOQ, economic order quantity. So with this we have discussed the shortage model. Next model we will discuss about the inventory model, and that will come with the buffer stock, or we can say safety stock. Of inventory model with safety stock. So we will discuss the inventory model with safety stock. So we will talk about the safety stock and what is safety stock, and we will discuss about the safety stock model. So this is the simple plot between the order quantity, or we can say quantity and time. So in the quantity we have economic order quantity. So we are getting economic order quantity, and economic order quantity, so we are consuming this economic order quantity, and at particular period time we are thinking that one level has come, so that we have to place order, because if you will place the order it will take some time and to deliver, and the time between placing the order and delivery of the order is nothing but the lead time. So we have lead time 1, and lead time will be there. So lead time may vary, so we can have average lead time, and that is delta LT. This is nothing but the average lead time. So we have average lead time. So at first we will receive the order, and with the time we will consume that order, and at particular some point of time we will come to know that we have a minimum quantity, so that we have to place order. By the time that order will come, we will complete the remaining quantity. So this quantity will consume, and at the same time next fresh order will come. Again we will consume that, and it will go on. So here we don't have any safety stock. We are not maintaining any minimum requirement of a stock for any for any worst condition or for any you can say if you have something goes wrong in the future, we don't maintaining, we are not taking about that, we are not making any factor of safety, or we can say safety stock. So we have to, in the industry or in the some firm or in where we have to maintain a stock, some safety stock, and we will discuss that stock how we have to maintain. So we have to maintain some stock for future, for safety, for any worst condition, and that stock can be maintained. So we have this is plot is between quantity and time with safety stock. So we have maintained some stock. There may be chance that at the time of delivery it will get further delay. It may go for 2-3 days. More time it will take. So for those reasons, what we are doing is we are making some safety stock. So there is a chance that something goes wrong and there will be a delay in the delivery. So we are maintaining some stock for future worst condition, and that stock is nothing but the safety stock. So safety stock, we will also know it as a buffer stock, is a stock we are maintaining for any worst condition or for something is wrong or something goes wrong. So for that condition we are maintaining the safety stock, and that stock to be maintained throughout the period. We are not consuming that period, and if something goes wrong, then at that time we will consume that particular quantity. So that is the safety stock we have. So we have two new terms over here, and 3 new terms, and that is reorder level, and another is the safety stock, and another also is lead time. So we have talked what is lead time. Lead time, if you are placing order today and if you are getting the order after 3 days, so this 3 days will be nothing but your lead time. So 3 days will be your lead time. So this is the concept of lead time. Reorder level means one level or some point will come. At that point you have to place the order so that you can get the delivery at your time on time. So that level is the reorder level, or you can say that point is the reorder point. So we will discuss about the lead time. We have the time taken between the initiation of the order and receiving of the material is nothing but the lead time. Average lead time will be some value. So if lead time is varying time to time, so if some value is coming like 15, 20, 19 like that, 21, so we will make an average, and that will be the average lead time. In this case, if you don't have any safety stock, so in that condition we have maximum inventory we have is how much time max, and minimum inventory is 0. You don't have any safety stock, so here you have maximum inventory, and that inventory is Q max, and that is Q star, and that is economic order quantity. And with the completion of the period, you don't have any quantity, so minimum inventory is 0. But in this case, if you are maintaining some safety stock, so you have maximum inventory Q star plus SS, that is safety stock. So you have maximum inventory, that is optimum order quantity, economic order quantity, and safety stock. And minimum inventory, how much we are maintaining is safety stock. So that is the minimum inventory. So if you have without safety stock, then this will be the inventory level of inventory, and with safety stock you have this is the level of inventory. Few more terms we will discuss over here, and that reorder level we have discussed the amount of inventory in which in stock when an order is placed. So if you see this quantity has came, then we will say that we have to place the order, because order will take some lead time, so that we have to place the order so that we can have delivery of the order on time. We can find the safety stock by the formula maximum lead time minus average lead time into consumption rate. So maximum lead time minus average lead time into consumption rate will give you the value of safety stock or buffer stock we can find. So now we will discuss one problem, and with the few terms we will discuss with the help of problems. Some questions, some terms we have already discussed. Like EOQ, we have already discussed what is EOQ in the other models. We will see the formula for also this. So some parameters we have given. Annual consumption, that is A, annual consumption A is how much, 10,000 quantity. Cost of unit for means one cost is we have here rupees 1. Setup cost is rupees 12. So this is we have to have setup cost. Yes, rupees 12. per production days. Setup cost generally for per production run means if you are producing one time, you have to pay a setup cost of rupees 12. Unit cost is that is C, and that is how much unit cost is 1 rupee. We have to pay inventory carrying cost, and that inventory carrying cost is 0.24 rupees per unit. And lead time we have given, lead time is 15 days, 25 days, 30 days. So we will find from this value the average lead time, and we will find the maximum lead time, and that maximum lead time we have is 30 days. So first we will find the average lead time, and that average lead time will be 19 days. So we have average lead time 15, 25, 13, 14, 30, 40, 6, 17 plus and we are dividing by 6 because we have 6 numbers. So we are getting the average lead time. Next we will find the consumption rate. What is the consumption rate, and that quantity consumed, time taken, and how much quantity is consumed. 10,000 quantity consumed, and time taken is how much? 365 days for 1 year. So quantity consumed is this much, 27.4 units per day. So this is the consumption rate. So from this we can find the safety stock. Safety stock is maximum lead time minus average lead time into consumption rate. So consumption rate 27.4, maximum lead time 30 days, and we have average lead time is 19 days. So from this value we can find the safety stock. So we have to maintain a safety stock of 302 units. We have lead time of how much? 19 days. Average lead time is 19 days. We have a safety stock of 302 units. We have also a consumption rate of 10,000 per year. We have annual demand consumption of 10,000 per year. So next we will find the reorder level. We will go for finding the reorder level. So prior to that we will find the economic order quantity. And we know the formula for finding the economic order quantity, 2AS by CI, where A is annual demand, S is called setup cost per production run, and CI is the inventory carrying cost. So we can find we have annual demand 10,000 units, and setup cost per production run is 12 rupees, and inventory carrying cost is 0.24 per unit. So we can have a economic order quantity is how much? 1,000 units. So we have a annual demand of 10,000 units. We have economic order quantity 1,000. So number of orders will be how much? 10. So here we have maximum inventory is Q star into plus SS, and that is 1,000 plus SS is safety stock is 302. So we have safety stock of 302. So we have economic order quantity, and that is EOQ, and that is how much? We have EOQ is 1,000 unit. This is Q between and T. So we have also some. So we have quantity, how much economic order quantity is 1,000, and we have a demand of economic order quantity is 1,000, and we have a demand of how much? 10,000. So number of order 10. So this particular cycle will be 10 times. Next we will find for reorder level. So reorder level we will find. We will see the reorder level. We have a lead time of how much lead time we have given, and that lead time is average lead time is 19 days. So average lead time we have 19 days, maximum lead time 30 days. We have 1,000 units. So this is the EOQ Q star, and that is. So we are making one reorder level. We will see the maximum inventory here. How much is Q star plus SS. So safety stock we have how much safety stock we can say we have. So we have also safety stock. So this will be the T, and safety stock is how much? 302. So quantity of 302 will be the safety stock we have. So maximum inventory will be how much? EOQ is safety 1302. 1,000 plus 302. So this is maximum inventory will be 1302. Minimum inventory will be safety stock, and that will be 302 unit. We can find the reorder level, or we can say the consumption reorder level. And reorder level we can find by the formula. Reorder level we can find by average lead time into consumption rate plus safety stock. Consumption rate we have 27.4. Safety stock is how much? 302, and we have average lead time 19. So this will give the 823 is the lead time. So from this we can find the reorder level is 823 days. So we can have a plot of we can have a plot of time. We have quantity. There we have economic order quantity, and that is 1000. We have safety stock, and safety stock is how much? We have to maintain a safety stock of 302. We have a reorder level. So we have reorder level also. So this reorder level will be how much? So reorder level will be including the safety stock, that will be the 823. So this quantity will be 823. 823. So at this particular time, and lead time is how much? Lead time is the 19 days. So this is the 19 days. So this is the diagram. This is the plot for the economic order quantity and time. So this will be the complete consumption time. So this is the consumption time, consumption rate. We have consumption rate 27.4 in consumption rate. So this is the diagram for the inventory model with and without safety stock. So if you are maintaining safety stock of 302 quantity, you have minimum inventory of 302 all the time. So you have to pay 302 carrying cost, and maximum inventory you have is 1302. So we have discussed one problem related to safety stock. So with this, we have completed 4 different models of inventory control. So we have discussed 4 different models of inventory control. One model is about the basic of the inventory control, that is the economic order quantity. Next, we have discussed about the production, simultaneous production and consumption model. So in which we are producing, not only producing, we are also consuming with the time. We have also discussed about the shortage. So if you have shortage, we have to make a target that we have a minimum shortage. And finally, fourth one model, we have discussed about the safety stock, or you can say this is the buffer stock, in which we have discussed about the safety stock, reorder level, average lead time, and consumption rate. What is the consumption rate, safety stock, all these things we have discussed. What is the maximum inventory and minimum inventory. So thank you so much for attending the class. We have discussed all about the inventory control. Thank you so much.